Hello everyone, thanks for attending CERAWeek 2024. My name is Edward Saladavedruna. I'm a Vice President within S&P Global Commodity Insights, and I'm leading the Clean Energy Technology Group. Here today, I'm with Mark Lundstrom, CEO and founder of Radia. Mark, how is CERAWeek going for you?
It's been a great year. Having been to CERAWeek now for probably about 8 years or so.
8 years already?
It's been wonderful to watch the progression of Agora and all the new technologies that are shown in Agora. So it was a fantastic place for Radia to come and share some of our unstealthing and are coming out this week. So we've been excited to be here, and the business development opportunities have been fantastic.
That's great. So can you tell us what Radia does?
Sure. So Radia is enabling gigawind. And so imagine offshore-sized wind turbines that are the size of the Eiffel Tower deployed onshore. And today, of course, onshore turbines are much smaller, much shorter, much less powerful than offshore turbines. They could be half as powerful as the offshore turbines, maybe even a third. And so if you could supersize onshore wind, you can double the capacity of the turbine. You can reduce the cost of the electrons by 30%. You can increase the consistency or the utilization by 20%. And you can triple the acreage in the world where wind is economically viable. And so Radia is enabling gigawind, but it's not possible today to have large format turbines like that onshore because of simple terrestrial transportation constraints. A 105 meter long blade is too long to make it around corners, it's too wide to make it under bridges, it's too tall to go through tunnels. And so we work with almost all of the major turbine manufacturers in the Western world and some of the biggest internationally in China to enable them to move these supersized turbines to onshore locations. And the way we do that is by making, quite simply, the world's largest aircraft. And so it's a very, very big airplane that allows us to move a 105 meter long object that can weigh up to 75 tons. And one of the special things about it is it allows us to land on dirt in the middle of the wind farm.
But Mark, excuse my question, right? But an aircraft, right? We don't have other options to transport all this very big equipment?
Yeah, so terrestrially we really don't. And that's why offshore wind have blades that are now up to 115 or 120 meters long. But onshore, usually you're limited around the 70 meter range or so. And so
because of logistics.
Because of logistics. I mean, the physics dictate that we should go bigger. The physics and the economics and the growth of wind over the decades has all been about just going bigger and bigger and bigger. But now we start to face these logistical constraints, because how do you move a blade that's 80 meters or 90 meters or 100 meters on the road? You just can't. And so they're too wide, they're too long. And so we started exploring 6 years ago, we started exploring how do you make an aerial transportation system in order to move these largest objects. And we did look at rotorcraft, we looked at helium, we looked at modification of existing aircraft, and then realized that the best way to go about this is to make a fixed-wing aircraft that resembles sort of a military cargo airlift vehicle, but is made with largely off-the-shelf things that are already flying in the aerospace industry today. So the team has done a fantastic job of designing a new aircraft, but around the components that are already in mass production and certified.
So it's just designed just to feed a blade, to feed a big nacelle, etc.
Mainly blades. We could do some towers too, but also, and then there's some other payloads that we could do outside of the wind industry as well. Of course, it'll be the world's biggest aircraft by volume, by far. It's about 12 times bigger in volume than a 747. So that's a very large vehicle.
That's quite big.
Yes,
that's quite big. And one question is that because we are hearing at CERAWeek, we are hearing about the cost of solar, of the other technologies. So my question to you would be, why wind?
Sure. Well, I guess it goes back to celestial bodies, right? The Earth rotates once a day, the Earth orbits the sun once a year, and so solar is good sometimes, but it's not good all the time. And so it's hard to beat solar in Arizona in the afternoon and the summer, but on average, solar is not cheaper than onshore wind today, according to Lazard, for example. And with gigawind is yet less expensive than onshore wind. So this will be the cheapest energy. Now, solar is, the cost curves have been amazing, and so we actually view solar as more of a complement than a competitor in many ways, because Solar and wind match each other temporally very well, both on a daily basis and on a monthly basis, because of the rotation of the Earth and the rotation of the Earth around the sun, and so the solar will be much stronger during the day, and the wind will be much stronger at night. So it balances out. So you have you can put more renewables into the grid if you have solar during the day and wind at night. Likewise, solar is better in the summer, wind is better in the winter. And so this is really important because in the next decades, there's a few trends that are happening that will actually push demand into the hours and the months where wind is most important. And those trends are things like heat pumps. Heat pumps, right, today, the peak demand for energy is summer due to air conditioning. But as we start to electrify our heating, the peak demand is going to move from day to night. It's going to move from summer to winter. And so those trends for heat pumps move directly in the direction of wind. And then in addition, EVs, and with the proliferation of EVs, and when EVs represent half of the vehicles we're driving,
You charge at night.
you charge at night.
And another thing that we are hearing here at CERAWeek is artificial intelligence, right? And the data centers, they run 24 hours per day, right?
Yeah, exactly. And so that's the third trend that I would mention, which being able to provide 24/7 green energy, 365, as proximate as possible to the data centers is very important. And so if you're trying to power your data center with green energy, solar gets you a lot of mileage during the day, but if you're trying to complement that with batteries, that gets very expensive. So again, complementing solar with wind is the best way to get most of the way to powering a data center 24/7.
And this concept of developing very large turbines, is that exclusively in remote areas, or are we trying to untap the potential as well close to the load centers?
Yeah, so the large turbines have the flexibility of operating in more locations. And so with the bigger turbines, you can operate in much lower wind speeds. So instead of 7 meters per second on average, we can operate in 5 meters per second. This triples the acres in the world where wind is economically viable. And so we have the luxury of the flexibility to now start to site turbines and wind farms where turbines today cannot be sited economically. And so it gives you a lot of flexibility to get much closer to demand centers and to start to reduce the amount of transmission that you need in the renewable transition.
Mark, that's very interesting. So one of the things that we are hearing, one of the themes that we are hearing here at CERAWeek is about how do we build all this new power generation capacity that is going to be needed, especially in the US, to fulfill the demand. And two things come very often in the discussion. One, challenges around permitting, and the second is challenges around grid and grid deployment. How do you think that Radia can contribute to overcome these issues?
Sure. So with the bigger turbines, with GigaWind, we're able to both reduce the amount of transmission necessary and make more effective use of the transmission that is out there. And so you can reduce the amount of transmission because with the bigger turbines, you can operate in the lower wind speed. You can bring your power generation closer to your demand center and shrink the amount of transmission that's needed, which is really important because permitting transmission is just as hard or harder than permitting wind farms. And then secondly, with the larger turbines, you are able to make more efficient use of the transmission lines that you have and the interconnects that you have. The bigger turbines operate about 20% more of the time, and so that means if you've reserved a certain amount of interconnect capacity, you can just use that more of the time, get more benefit out of the interconnect that you've reserved. And so for those two reasons, GigaWind really GigaWind is favorable for transmission purposes.
Yeah, and one of the points that you made earlier, right, is that you can pick and you can choose sites that in the past were not economically viable.
Yeah, all of the best wind sites have already been picked over, of course. And so with the bigger turbines, you can start to move into the medium wind speed areas and the lower wind speed areas and really open up the universe for where wind is economically viable, permittable, and where you can get transmission and interconnect.
Oh, fantastic. And another of the themes that we are hearing here is about hydrogen, and it's more about the green molecules, right? And greening the molecules. What is, in your view, what Radia can bring to the table?
Yeah. So even though Radia is focused on GigaWind, and we're focused on, people would, I think, assume that we're really just looking at wind, but wind in the end is a...
Well, it's in your name, right?
It is. But in the end, GigaWind is a strategic weapon, essentially, for green molecules, or most of the vectors in the energy transition. And so whether it's green hydrogen, green ammonia, sustainable aviation fuel, methanol, direct air capture, the principal thing that all of those things have in common is the unit cost from green power is the number one driver of the unit cost of that end green molecule. So if we can help reduce the cost of the green energy that goes into making all of those green molecules, we can drop the cost of all those green molecules by about 20%. And so not only is GigaWind great for the grid, it's also great for making green molecules.
Exactly, and you alluded to another aspect as well. You said the higher utilization, right?
Yeah.
For an electrolyzer, it's important to run it for a longer period of time. So it's LCOE plus utilization.
Correct, yeah. And so this is any time that you have a lot of capital expense, and that could be electrolysis, it could be Haber-Bosch, it could be data centers. Any time that you have a lot of CapEx, and you want to make sure that it's powered 24/7 with renewable energy, it's better to have GigaWind because you can reduce the cost and increase the utilization.
So yeah, you alluded to many different things. So if you had to summarize what is Radia's value proposition, how would you summarize it?
Yeah, so Radia is first and foremost an energy company rather than an aircraft company. What we're doing is we're building an energy company with a proprietary technology that allows us uniquely to supersize turbines. As that energy company, then, we're able to have a lower cost of energy and a higher capacity factor. And so by being able to reduce the LCOE and increase the capacity factor, we're able to oftentimes double or triple the profitability of projects. And so in the end, the consumers end up with lower cost of energy, and the industry involved can make more profit at the same time.
Yeah. So thank you very much. Thanks for the time. Thanks to all of you for attending CERAWeek 2024, and see you at CERAWeek 2025. Mark, thank you very much for being with us today.
Thank you.
Thank you.